let me go back to the definition of limits again. So a limit is the value that a function or a sequence approaches as the input or index approaches some value. Why do we talk about index? If we talk about index, we are talking about sequence. If we are talking about the input, we may be talking about the function. So all we are concerned here is not the sequence. We are concerned about functions. What is the limit of a function? So I give an example. If you have a function f of x equal to 2x, and the values of x, that is the input, first I give 0.9 as my first input. F of 0.9 is 1.8. Okay, I give another input 0.99. Then f of 0.99 is 1.98. I give another input 0.999. F of 0.999 is 1.998. As I am increasing the number of nines in after the decimal place here, the value of f of x is also increasing, approaching some value. So as I increase the number of nines, 0.999, this value will approach 1. Okay, if this value approaches 1, what is the value of this function approaching? Which value is our function approaching to? So as x is approaching 1, the value of this function is approaching 2. So in this case, we can say the limit as x approaches 1 of this function is equal to 2. So this table will help you understand the idea of limit. So from the above table, we can observe that as the value of x is increasing and approaching some value 1, the function's value is also increasing and approaching some value, which is 2. So with this, we can conclude that the limit of this function as x approaches the value 1 is 2. So if we have something like this, we can say the limit of this function as x approaches 1 is equal to 2. In other words, as the value of x approaches 1, the limit of the function is 2. It is written as limit as x approaches 1, you can see it from the slide, of f of x is equal to 2. Or limit of, just write the expression and the definition of our function, which is 2x. Limit as x approaching 1 of 2x is just equal to 2. Well, let's see. This is how we read it. It's given in the slide. Limit as x approaches 1 of f of x is equal to 2. Or limit of f as x approaches 1 is equal to 2. So that is the idea of limit. If the limit of a given function is a real number, then that limit is said to exist. Otherwise, it does not exist. If the limit of a function is plus infinity, minus infinity, that limit does not exist. If it is 0, it exists. If it is a real number, it also exists. So if the limit of a given function is a real number, then that limit is said to exist. Otherwise, it doesn't exist. If f is a function and f is a polynomial, and we know what a polynomial is, then the limit of f as x approaches some value is just f of that value. So if f is a polynomial, the limit of that f as x approaches some value is f of that value. So example, evaluate the following limits. The first one is saying, what is the limit as x approaches 0 of 3x minus 5? 2. Limit as x approaches 1 of x squared minus 3x minus 5. And 3. Limit of x squared minus 4 over x minus 2 as x approaches 2. So this is what we have. So solution. To get a clear picture of this number 1, you can draw a table just like what I did. draw a table, put some values that are approaching 0 of x, maybe 1.000, no, that is approaching 1. Find some values that are approaching 0, just like 0.999. No, that is also approaching 1. Find some values that are approaching 0, try it and see, put it in the function and examine or notice what is the value of this function going to. So find some values of x that are going to 0. Just like if you have x to be 0 0.5, 0 0.4, 0 0.3, 0 0.2, 0 0.1, 0 0.01, 0. So this value automatically is approaching 0, 0 0.001, 0 0.0. Increase the number of zeros, 0 0.00001. Observe what is the value of this function. Observe it and see. So automatically it will be approaching -5. So use the table or use just what I said about a polynomial, because 3x minus 5 is a polynomial of degree 1. So we can use that as to find the value of our to find this limit. So 3x minus 5 is a polynomial, so f of 0 there is just -5, but it's good to use the table, find some values that are approaching 0, then examine this value, the value of this function, where is it going to. You will see that the value will tend to -5. So 2, limit of x squared minus 3x minus 5 as x approaches 1 will be -7. Try it also, find some values that are approaching 1. Let's say 1.00001, 1.00001, that is approaching 1. Also 0.99, the one I used in the table, is also approaching 1. Put it in this function and just observe where is the value of the function approaching. You will see that this limit will be -7. So the third one is limit as x approaches 2 of x squared minus 4 over x minus 2. This is slightly different from the first two examples. If you substitute 2, you will have 0 over 0, and 0 over 0 is something not defined, or plus infinity, or something that is not defined. So we need to do some manipulations, we need to do some arithmetic, we need to factorize, or if you are dealing with a surd, if our function is in surd form, you need to factorize it, you need to do some manipulation so that it will be more friendly to work with. Just like this, it's x squared minus 4 over x minus 2. You need to do something to evaluate the value of this limit. If you say this limit does not exist, you may be wrong. But if you try manipulating, try some mathematical approaches to see how you evaluate or how you express this function in its lowest term. So you have x squared minus 4 over x minus 2. Remember, 4 is 2 squared. So x squared minus 2 squared. So x squared minus 2 squared is just difference of 2 squares, which is x minus 2, x plus 2. If you have that, x minus 2, x plus 2, x minus 2 will go with x minus 2. So now you have limit as x approaches 2 of x plus 2, which is 4. So you see, if you say the limit does not exist, and you have automatically failed the question. So this limit exists and it is equal to 4. So if you are given something complex, try and simplify it. If you can simplify it, perfect. If you cannot, then don't say that limit does not exist. You have to exhaust all the possible options to see. So in this case, we have um, simplified our denominator, which is x squared minus 4. We simplify it, is x minus 2, x plus 2. X minus 2 will go with x minus 2, and this limit is equal to 4. So I will send you more examples that you practice and see, and you will find it very easy. There are some tricky limits that are very difficult to evaluate. So if you have any difficulty, any problem, just ask me. So let's see limits at infinity. What will be the value of a function as x, if the function is in the variable x, as x approaches infinity? That is, as x is increasing, moving towards infinity, what will be the value of our function given in that situation? So consider the following function, f of x, which is 1 over x, for x not 0. If x is 0, this function is not defined. So x is not 0. We are given the function 1 over x. We want to see as x approaches plus infinity, what will be the value of our function 1 over x. So I use the table also here. This is x, and this is f of x. First, we start with the value x equal to 10. If x is 10, f of x will be 1 over 10, which is 0.1. If x is 100, f of x will be 0.001. If x is 1000, f of x is 0.001. So as the zeros of x are increasing, the zeros of f of x are also increasing, but the zeros of f of x are behind decimal point, like 0.000 at last 1. So you can see we have 1000, we have 100,000, 10,000, we have 100,000, we have 1 million, we have 10 million. We have the values of x are really increasing. They are approaching plus infinity. So x is approaching plus infinity, but our function's value is moving towards a number, towards 0. So as x is approaching plus infinity, the value of our function is approaching 0. So this is how we evaluate limits at infinity. As x is approaching infinity, the value of this function is approaching 0. So this is, so from the above table, we can observe that as the value of x is getting larger and approaches infinity, the value of the function becomes smaller and smaller and approaches 0. Therefore, the limit as x approaches plus infinity of 1 over x is 0. Or this limit is 0. So example, evaluate the following limits. We don't know whether they exist or they doesn't exist. If the limit exists, find it. If the limit does not exist, then you cannot find it. Just show us why it doesn't exist. So number 1, limit as x approaches plus infinity of 2x. So this is easy. You can pick the table. You can use the table. Find some values of x, just like the way we used 10 in the first example. Use 10. If x is 10, f of x is 20. If x is 100, f of x is 200. If x is 1000, f of x is 2000. If x is 10 million, f of x will be 20 million. So as x is approaching infinity, f of x is also approaching plus infinity. So the limit as x approaches plus infinity of this function is plus infinity. So the limit does not exist. I said if the limit of a function is a real number, then that limit exists. If it is plus infinity or minus infinity, it does not exist. So this limit does not exist. So limit as x approaches plus infinity of 1 over x squared. You can use the table. If x is 10, 1 over x squared is 1 over 100. 1 over 100 is 0.01. If x is 100, f of x will be 100 squared, 1 over 100 squared. So as x is moving towards plus infinity, our function's value will go to 0. So this limit, it exists and is equal to 0. So 3. Limit as x approaches plus infinity of minus 2x. The function is minus 2x and x is approaching plus infinity. If x is 10, f of x will be minus 20. If x is 100, let's say x is 100 moving this way, f of x will be minus 200 moving this way. So as x is approaching plus infinity, f of x will go to minus infinity because of this negative. As you put 10, f of x will be minus 20 this way. As you put 100, f of x will be minus 200. It will approach minus infinity. So limit as x approaches plus infinity of minus 2x is minus infinity. So this limit does not exist. Now, limit as x approaches minus infinity of minus 2x. X is minus 10, f of x will be 20. If x is minus 100, f of x will be 200. So as x is moving towards minus infinity, f of x will go to plus infinity. So this limit is plus infinity. Limit as x approaches minus infinity of x squared is plus infinity, because if x is, let's say, minus 10, f of x will be 100. If x is minus 100, f of x will be minus 100 squared, which is 10,000. So as x is moving towards minus infinity, f of x will go to plus infinity. So this limit also does not exist. Number 1, 3, 4, and 5 have no limit. So the last one, number 6, is limit as x approaches plus infinity of 2x power 4 plus x cubed over 4x power 4 minus x squared. How do we evaluate this type of limits? First, our variable here is x. What is the highest power of the variable? Locate or find the highest power of the variable. The highest power of the variable is 4. So that means divide each term by x raised to the power 4. Each term, as we do here, is 2x power 4 over x power 4 plus x cubed over x power 4 over 4 this over x power 4 this. So x power 4 will cancel, you'll be left with 2, and you'll be left with 1 over x, and over 4 minus 1 over x squared. And remember, in the previous examples, we said limit as x approaches plus infinity of 1 over x is 0. Limit as x approaches plus infinity of x squared of 1 over x squared is 0. So this will go to 0. Have 2 plus 0 over 4 minus 0, which is 2 over 4, which is 1 over 2. So as x approaches plus infinity, the function value will go to 1 over 2. So this limit exists and it is 1 over 2. So this is how we evaluate limits at infinity. I will send you more example, practice it, try it. If you have any problem, ask me anytime and I will answer you. So this is it about limit. Now continuity. So continuity is slightly different with limits. So a function is continuous. This is a layman definition. A function is continuous if when you are drawing the graph of that function, you don't have to lift your hand. Let's say I want to draw a curve. In drawing a curve, I don't have to lift my hand. then this curve that is representing a function is continuous. So if you draw the graph of a function without lifting your hand, that function is continuous. If it is a straight line, it will give you a polynomial of degree 1, and every polynomial is continuous. So if you are drawing the graph of a function without lifting your hand, then that function is continuous. Let's say I am drawing something like this, and I lift my hand, continue, then this function is not continuous at the breaking point where I lift my hand. So there are conditions that represent all this analytically, which we have here. So a function is continuous at a given point if some conditions are satisfied. So the idea of continuity is this: if you are drawing the graph of a function without lifting your hand, then that function is not continuous. So a function is said to be continuous at a point A if the following conditions are satisfied. The first condition is f of that point exists. Limit as x approaches that point of f of x must also exist. And the last point is limit as x approaches a of f of x has to be equal to f of a. If they are not equal, if any one of these conditions fail, then that function is not continuous at that point. All these three conditions has to be satisfied. If one fails, then the function is not continuous at the given point. Example, check whether or not the following functions are continuous at the given points. In the examples, I gave a function and values at the side of the function. Check whether this function is continuous at these points. Number 1, f of x is x squared minus 2x plus 1. Check whether this function is continuous at x equal to 0. Number 2, f of x is x squared minus 2x plus 1 over x minus 2. Check whether this function is continuous at x equal to 2. So next time I will give example of how to show continuity of functions at a point. See you.